Hi. Yes.
Just before you start, just for the exercises for this week,
Yeah.
there was an algorithm to calculate, the arrays, and just
Yes. Sure.
it was the if you have
Is it this one or?
oh no, it's exercise 02.
Oh, today we are going to talk about 01.
Oh, okay.
So
Oh, so the exercise 02 will be corrected next week?
yes. So
Oh.
I think you're far ahead of the pack already. Yeah.
Okay.
But did you guys talk about exercise 01 already last week?
Because last week we started, but
Okay, that's interesting. But yeah, typically we teach like exercise 2 this week. Then we will talk about next week.
Okay, yeah. Because I tried to do exercise 2 and like there were some things that I don't understand.
I see. Yeah, but we'll cover it next week. No worries. Okay. Okay. Hello everyone. So is everyone here for big data tutorial? Okay. Yeah, I'm Hongyu. I will be the TA of this session. Okay, let me connect the screen. So in the meantime, yes, so nothing. Anyway, so this is my okay. Name, and you can reach me at my email as well if you have any questions. Yeah, please let me know. And today we will basically talk about two things. One is the relational databases in general and normal forms, and some SQL brush up, right? So we can run this session in two ways. First, I have some agenda, like I can talk about things I think might be interesting to you and also useful for the exams. And then I can quickly go through every single question, and please interrupt me anytime you have any problems with any of the questions on the notebook. Or we can, driven by you guys, like if you have questions, you come up, and which one do you prefer? First one or second one? First one? Second one? Okay. Then we will go with the first solution. So I think I will briefly talk about first normal forms, because I think that was one of the things I found difficult when I was first studying it and when I was undergrad, and also when I was reviewing it for this course. So basically I think the way I learned normal forms, especially I think in this course, we will mainly talk about the first three normal forms, right? The first three normal forms. And I think in my year, we also touched upon BCNF, which is boys normal form, but I think it's not a thing this year anymore. So I think the most like effective way is to create some mnemonics and to create some counterexamples. I found they are very contrived examples, but I found they are very helpful. That they help me a lot to understand those things. So first normal form. Yeah, so what's like a difference about first normal form is that it's concerning mostly with individual cells, right? That's why it's called like first normal form, right? It has a one, and some counter examples to illustrate the things that violate the normal forms. Let me increase the context a little bit. Yeah, so you have like mixing data types in one cell. This is not allowed, right? For example, Rachel, Monica from France, and you have Phil. This is not allowed. And also, you can't have a table without primary key. For example, in this case, you could have two Monicas with the same grades. And this is a typical example of data inconsistency. And also we can have something called repeated groups, meaning that you have a list of values and multiple values within one cell. For example, you have grades and you can kind of have this dictionary kind of format. So any ideas how to, for example, fix this repeated groups within a cell? Like any methods coming to mind? Okay. Okay. I think that's a very advanced solution. So what I come up with first is just to flatten the table. I think the better solution is to split the table into multiple atomic tables, and we will see why that's a better solution. But for now, what we can do is to, we have two columns, right? We have a course, we have a grade, and we have a name. And this table basically adheres to the first normal form. And the rules here for the first normal forms are like, you can't mix data types within a single column, right? You can't have tables without primary keys, and repeating groups are not allowed either. And the last point, which is kind of rare, is that you can't use the row order to explicitly tell the some meaning. For example, you rank their grades, and to expect the user would know that the order means something. Okay, moving on to second normal form. Any questions at this point? Yeah, please. Yes, so I think in my understanding is basically a list of objects. And you can have this like, for example, in this case, math and like grade 5 would be a group. Yeah. And yeah, does that answer your question? Yeah. And yeah, by the way, why don't we just like create these things, like create this as a string, and we encode it into your database directly? Please. Yeah, that's true. That's true. So it's a terrible design, as you said. So you can't really, correlate very effectively. For example, I want to know Chandler, what's the physics grades of Chandler, and I need to get the string and parse the string myself and do nasty stuff. Yes. Let's continue. For the second normal form here, another contrived example, let's add the school information to the table, right? For example, Chandler is from EPFL and Monica is from ETH. We want to know the school they are coming from. And now we are having the first, yeah, let me check. Yeah, the first anomaly, which is the deletion anomaly. So for example, we want to say, the grade for Chandler is wrong. We want to delete it, and suddenly we've lost information for Chandler. Like we don't know to which school does Chandler belong. We no longer knows that. This is called the deletion anomaly, and we also call have update anomaly in this table. Could happen. For example, we want to update, for example, a Monica transfer to APFL, and when doing this updates, the database busy doing this update, and something happened because it's not an atomic operation, so it can break in the middle. And in this case, the last row was not updated. And so this also causes the data inconsistency. So what the origin of these problems is that this table is not adhering to the second normal form, which is that each non-key attribute must depend on the entire primary key. So in our case, this table is no longer having a single primary key, right? We are having a composite key, which is the name and the course, right? So in this case, we can see the primary key is name and course, and the non-key attribute are grades. So what we can do is that we can do some checks, right? For example, we can check, okay, for those non-key attributes, when we are checking for the second normal form, so the grade is depending on both name and course, but the score is only depending on the person, right? That's why we are having this table not adhering to the second normal form. Yeah, question.
I didn't understand how this means that the school doesn't depend on the name in this. Because for the grade, we checked if it depends on both the name and the course, because they are a part of the key.
Yeah.
But why for school we checked depends on only the name?
Yeah, that's a good point. I think so. What I wanted to say is that a school is not depending on the both name and course. So school is only dependent on name.
Yeah, so the question is more like, is there a mistake on the table? Because it's with an ETH, ETFL, ETFL.
Oh, yeah. So this is, like the example for the two anomalies. One is the update anomaly and deletion anomaly. But this is the table we're addressing here. Yeah, so for this table, we are having a composite key, which is name and course. And ideally for every single non-key attribute, should depend on the whole key, the entire key. Yeah, that's the idea. Okay. Any questions? Yeah, please.
Are we, like, for the normal forms,
yeah,
in general, are we assuming that ACID holds for the database itself before we consider any normal forms?
Yeah, that's a good question.
Yeah,
I think we do. Yeah.
I think that your example of the deletion makes sense to me. Sorry, for the operating number.
Yeah, that's true. So for most databases, they would adhere to the ACID property, as you said. I think that's why I said it's a quite contrived example. So I think in terms of the implementation, the databases would do their best to like ensure like every operation is atomic. Otherwise, they will reverse the commit. But still, to make the database more efficient, you would have the tables to be like more atomic as possible. Yeah.
So if we assume that ACID holds for this, would an update anomaly be just that we have to update 3 rows when we change the school, or we maybe forget to update 1? That's like the user error.
Yeah, that's a good point. So if that property holds, then you wouldn't worry about that, because that would be a single commit. So because SQL is a like declarative language, so when you say you want to for this operation you want to update all ETH to EPFL, then in that case that's a single atomic operation. Either you do it as a whole, or you fail in between and reverse it back. that's what it would do. And typically, especially in the cloud, there will be like millions of users accessing the same table, and there will be failures. So it depends on the efficiency. If you are implementing table like this, it could be like you could try like 100 times before you success for the first time. That's my understanding. Yeah. Any questions? Yeah, please. Okay. So this is my own version. I will update all the notes and the examples to my GitHub, and I will post it. Let you guys know. Yeah, thanks. And also, yeah, some of the answers I really recommend double checking with the official answer because yeah, I added something to the official answers as well, just to make sure if there are any typos. Yeah, so moving on to the second normal form. So yeah, so what we can do, any ideas as to how we can do this? Like how we can normalize this table, this one. Because now we are having, say, one of the non-key attributes not depending on the whole key.
Into a students table and into a exam results table.
That's a good idea. I would take it. Okay. Yeah. So I think, yeah, whenever you have this case and you see, you know, a same attribute repeated for the same time, then you can, you know, if there is an option like splitting the table to something else, then that could be a better idea to reduce the redundancy. So all the normal forms, the main idea is to reduce the redundancy and to normalize the table to the leanest representation. So indeed, so in this case, what we have is that we can split the table into, as you said, like the grade table and the like affiliation table, let's say. So basically, in this case, for example, Monica in math solely determines the grade, and the name, and a name solely determines the score. And the mnemonic here would be like the second normal form often concerns with the composite key, which consists of often more than two columns. Right, so that's how I remembered it. So I found it quite helpful. Yeah. Questions? Okay.
Yeah, is that the only way to split the table? Like, couldn't you have name, like the other ways that you can split the table?
I think there might be. On top of my head, that was the solution, because so if you look at these two tables, both of them have a primary key, right? Like name, course. Yeah, I don't see immediately another solution. Yeah. Okay. Yeah. So for the third normal form, yeah, adding another contrived example. So now we are having a rating. So in this case, 6 is a good, right? 4 is a pass. So we want to know, like, based on the grade, we want to give a rating to every person and the course. But what if like Chandler's math grade was wrong, right? We want to update this to from 4 to 6. But again, like something failed in between, and we couldn't update the rating. So in this case, we created another data inconsistency, and this is due to the transitive dependency. So what transitive dependency says is that, so when we look at the two non-key attributes again, so the grade and the rating in this case, the rating is depending on the name and the course, so which is a composite key, and the rating here is depending indirectly on the primary key. Actually, it depends on the grade, right? So what we can do in this case is to like normalize the table again to make sure that for the third normal form, it's called every non-attribute in the table should depend on the key, the whole key, and nothing but the key. Okay, like import things addressing 3 times. So it worked for me. So for example, what we can do is that we normalize the table into split the table again into 2 tables, and to guarantee that, okay, every non-key attribute depends on only the composite key, the primary. Yeah, and the mnemonic here, you can see, the third normal form deals with the transitive dependencies, which often has 3 parties, right? The object, the dative, yeah. So, and another concept is the Boyko's normal form, but it's a bit nuanced, and it's just a nice addition. Basically, it says that every attribute, so this includes the key themselves, should only depends on the key. So in my life, I haven't seen in real life like a table that's adheres to the third normal form doesn't comply with B, C, and F. So I think if you see a table in a real application that adheres to the third normal form, you can safely assume that it also applies to B, C, and F. But don't quote me on that. It can happen, computer science. Any questions? Yeah, so the main objective I summarize, I wouldn't read it. So you can look at it once it's uploaded. So basically, the main objective of normal forms are like reducing the redundancy, right? We don't want to have redundant data. We want to update the data as efficiently as possible. We want to prevent all kinds of anomalies. We also have an insertion anomaly. I didn't create an example for that. And we want to, simplify the update process. But in short, we like the normalized tables are easier to understand, easier to enhance and extend, and and is protected from all kinds of anomalies. So I think you can think of the normal forms as like level of safeties, right? The first normal form is the bare minimum you can work with a database, right? Otherwise, you have syntactic errors, and then the second and third. Questions? No? Okay. Okay, then let's move on to the SQL exercises. Yeah. Have you guys gone through the exercises briefly? Okay, good. Okay, now I can assume that you guys are kind of familiar with the tables. So basically, we can execute some queries on the metadata of the table to see what the table looks like. Okay, this is not helpful. So we have basically 1, 2, 3, 4 tables, right? We have artists, released by, releases, tracks, and this is the artist table, artist ID. For the artist table, for example, we have the primary key, which is the artist ID. You have name, real name, a bunch of strings. And the question here is, what concepts are modeled in the dataset and how do we relate to each other? Any ideas? So I've written down the solution. So basically, the data sets consists of, like, as you can see, the artist releases and tracks. And the artist tables also contains information about the individual artist, right? And also it's identified by the primary key. And yeah, I wouldn't read all of that. And the shape of the table basically is chosen in a way that is mostly efficient to query. And also we'll find that we don't have like transitive dependencies in this case, as I introduced in previous example. And we also want to make sure that some queries are efficient. In that case, we might want to merge some tables in advance, because we have more reads than writes, then we can create views. But that's for later cases. For potential problems for adding the redundancies, I've shown you some counter examples as to why we shouldn't have redundancies as much as possible. And apart from like creating all kinds of anomalies, they can also increase the storage requirement as well.
SQL brush up exercise.
Yes.
That was created. So, like, isn't it best to do the exercising before graded quiz and not after, such that you can do quiz prepared?
Yeah, I think that makes a lot more sense, indeed. But the way the course is scheduled is that, you know, you have 1 week of delay, so that you have a week to work on the exercise. Then, you know, that's my job too. But yeah, I guess that's it then. So but in general, what I'm not really a good like SQL or like programmer per se, but general I found was good to deal with the exercises, especially SQL, especially during the exams, is that you break up the problems, you directly break up the problem into pieces, and you solve the problems by dividing and conquer. So give you quickly a few examples before you guys are bored. So these are the simple queries. So for more complicated ones, for example, for this one, so you want to select the most number of tracks. Then you first do, okay, I want to solve this problem. So this problem can be divided into several parts. And I first want to solve, you know, from inside out. I want to find, you know, the titles of those tracks and the corresponding counts. And then you can reuse it just by wrapping around another layer. So basically you are solving the problem like peeling the onions. And this is the same for the rest as well, because, you know, during the exams, you need to really come up with solutions very fast. So I think it's better to like look at the problems and divide them into parts and solve each of them directly without even thinking about that. And then you combine them by wrapping around. Using them as subqueries. So that's what I wanted to say. And you can ask comments, and you can use with. So apart from that, we also have JSONic tutorials. Yeah, please.
A lot of SQL in the exam.
I took it few years ago, so it was not a lot, but in my year, like the time was pretty constrained, so you need to write pretty fast, and the execution is quite slow. It's not like you're executing in a notebook. You are executing on a large data set, so you are expecting to have some execution delays. That's why I would recommend creating some problems yourself and then practice offline, just to get up to speed. Yeah. And SQL is not the only like programming per se questions you would have. You will also have Spark SQL, and you have JSONic. We'll talk about later. So yeah. So speed, accuracy. And also for the last question, we want to discuss the query patterns of like the SQL language. I think this could have some multiple choice questions. I've just added a bunch of other additional thoughts to the notebook. You can take a look at it later. Yeah, but basically, the exercise 4 and 5 are to motivate the rest of the courses like Spark SQL, like what is called MongoDB, for example, because SQL is not really was not really designed for unstructured data or to reason about graph databases and so on. That's why you guys also have the JSONic notebook. I hope everyone has seen it. No? Oh gosh. Let me check big data. So you should have access to the JSONic tutorial. So this week, the JSONic tutorial is very simple. So basically you would have, yeah, so you can access through, so you just go to RumbleDB, the official repository, and you can access for the week 1 tutorial notebook. And I recommend going through it because, so this week is pretty simple. You can see it's basically, yeah, so it's basically some syntax you can get familiar with, like arithmetic, logic, comparisons. Try them out yourself, execute them. There's nothing difficult like those SQL queries tricking you. So but next week there will be more exercise and to query like more complicated data structures and so on. So highly recommend looking at it if you haven't. Yeah, I think that's it. Question. Yes, that's true. Yeah. Glad you asked. So basically, you should also check up alongside the database, not database, big data repository. You should also check every week this repository for updates of the notebook. So typically there will be a companion notebook together with the exercises you will get. Okay. Yeah. Great.